Hello students and welcome to another video. Today we're going to be talking about how nuclear reactors work, okay? And just to give you a frame of reference, about 10% of the world's electricity comes from these types of reactors, all right? And to give you more perspective, the amount of energy that's created from a uranium-235 atom creates about 3 million times the energy of coal by mass. Okay. You can find that information directly from the book. I think it's relevant information. If you think about it, if you think about the size of a small Coke can, how much energy that could create. Like if you had a small amount of energy, it's 3 times the amount, million times the amount of energy created by coal. So you'd have to have 3 million, to say, Coke cans of coal for every 1 can of uranium-235. So the energy concentration is very high for uranium-235. And we're going to go through and explain this process of how it works. So there's three really systems that are going on in here. We have the reactor itself that has a coolant that's flowing in and out of it. We have a water steam generator, and then we have water that's cooling down this water steam generation on this other side. And let's talk about this first part of this reactor. So what we've got here is three different types of materials. We have the actual fuel rods, which is the uranium-235, and that's the red. The blue is the control rods, okay, and then the black is the carbon moderators, okay. And a lot of times these graphite or carbon moderators will slow the reaction down, okay, because we don't want to turn this into a bomb, okay. When bombs occur, we're having very neutrons being generated. If you watch the previous videos, you'll notice that there'll be neutrons that are generated from these reactions that will form a chain reaction that will cause this to rapidly react. And that's what a bomb is. But what we're doing is we're controlling that bomb by slowing that process down by putting in carbon rods and control rods. And what's happening is it's heating up this coolant and it's going into this tank of water and it's causing this water to heat up and turn into steam. Okay. And that steam then turns a turbine, which puts out energy. Okay. And then that water falls down here and it's cooled down by water. Okay? You'll notice that most of these reactors are near the ocean or near a lake or near a place where they can put in cool water to help cool down the system so they can reuse that water to turn it again into steam and then turn this generator. Okay. There's even some, I think there's a Russian barge they're trying to create a nuclear reactor for. Nuclear reactions like this occur in submarines. These nuclear submarines can dwell for months at a time under the ocean because they're generating clean energy from the surroundings, essentially, from that cold water that's being pumped in. So just keep in mind, we've got three things that are happening. We have this coolant that's going around, that's heating up water, turning it into steam, and then we're cooling the steam down so that it can be reused and reheated from this coolant on this other side. And it's all happening because uranium-235 is decaying into another substance. Okay. And that's over time, these rods will run out of fuel and we'll have to replace them. Okay. That's the only limiting reactant for this problem is how do we get more of this radioactive substance? Because we only have a finite amount. But if you think about it, that finite amount of just having a Coke can's worth, that's about 3 million Coke cans of carbon. And the amount of carbon dioxide that will be produced from all of that coal is much worse for the environment than this small amount of radioactive waste. So if we're thinking about long-term solutions to climate change and other problems, nuclear reactions are the way to go, as long as we know how to learn how to control this reaction. And technology today has improved dramatically since the days of Chernobyl. Because in Chernobyl, what happened was they removed these control and moderator rods, and all of a sudden this uranium just started reacting much faster than it should, and it melted the uranium itself, and then it just exploded. And that's lessons that we learn in this process. Okay. And with all that's going on today with the climate changing and carbon dioxide production, and we want to limit that, this would be our next best thing until we can develop fusion. Okay. We'll talk more about fusion in class, and that's about how the sun works, about how we're fusing elements and harnessing that cleaner form of energy. Okay. Thanks again for watching. Till next time.